Okay, this is our first video for online lecture. I have made videos for my other class, and I have found, since this is very awkward and fake, meaning I do the best when I'm in a classroom, and since I have to speak slowly and clearly, that sometimes I start speaking like how I do when I voice text, and I start to actually say punctuation, like period. So if I do that, please forgive me. We're all trying to make the best of not a great situation. To recap where you should be and what you need out to get the most out of this video, you need your survey data out. Survey data. You need your dentist brushing the teeth problem. This is my personal sheet, but I think I Xeroxed it for you above the peanut butter sheet. You need your calculator, and you absolutely need these lecture notes. I had handed those out before spring break. I've also loaded that back into the Mayhem module in case you don't have access to the handouts. All right, before this video, because I know we've had a big break already, to kind of remind you what we've done in our statistics portion so far. We had a bunch of definitions about different types of variables and examples, categorical data, and the graphs that went with those. We then started numerical data. We did dot plots, stem and leaves, histograms. We talked about the shapes, the skew, also how the mean and median relate to that. Probably the first spot where students will struggle are the mean word problems. We did quite a few in class. Then there was the handout. I think the first problem started something about Harry. Answer keys are on Canvas, so make sure you have practiced all of that. When you're doing histograms, you have to work through the recipe, the guidelines that I gave you in your lecture notes. All right. This video I did not load notes for. I'm going to put up some notes on the board, but most of it is either going to be on here or you're going to practice things in your notebook. To get the most out of these videos for this entire online part of the semester, when I tell you to pause the video and go practice something, you do really need to do that. That's like when I let y'all work on your own in the classroom, see how you're doing on something, give you time to process and to practice, and then come back to the video. And of course, then we'll do it together, or there'll be an answer key, that type of thing. So please keep that in mind, that you have to kind of do your part to get the most out of this unusual presentation of material. All right, I'm going to erase this. So before break, again, we talked about mean and median as a way to try to describe the center of a data set. We talked about how the mean is really only good for unimodal and symmetrical distributions, but if you have skew or anything like that, you need to be using the median. But there's a problem with all that. The mean and median, that's an exclamation point, not a question mark. It's really only half the story. Here's a little made-up example. Right now, I'm attempting to draw two unimodal and symmetrical distributions centered at the exact same mean or median. I made them unimodal and symmetric, so we don't have to worry about whether we should be using the mean or the median. So they both have the same center. You guys are future teachers. It's very easy to look up what your starting salary would be for any public school county. But let's say your friends who are in a major, they don't know about how much they might be making, and they want to set their budget for after they graduate. Let's say they go to the internet and they read some starting salary. Let's just say $40,000. Well, your friend might actually think they have a lot of information right now, that they're probably going to make around $40,000. The problem is most websites do not show you a picture from where that $40,000 came from, nor do they give you any other information. So, kind of think to yourself, which distribution do you hope the $40,000 came from? We're hoping it came from this one. This is salaries down here. This one is representing, sure, you might make a little bit more or you might make a little bit less, but most of the people are making right around $40,000. So even if you made a little bit less, you can tighten up your budget or something. This one is so spread out that you might end up being rich or you might end up making hardly anything and you're living back home with your parents. So what are some words for this? The top picture has less spread, less variation, which means it's more reliable. So it doesn't matter that they had the same center. It's the spread that is as important as knowing what the center is. I'm going to erase. Knowing just the mean and median is totally useless without knowing the measure of variation. So we have two different measures of center. They each have their own measure of variation. The mean gets paired with something called standard deviation. We're also going to have to talk about something called the mean absolute deviation. That's going to be part of the next video. That information is in chapter 30.5. So we'll get back to that. Today's video is focused on the variation that gets paired with the median. It's called IQR, and it's in chapter 30.3. So, I was going to save you writing if we were actually in front of each other in the classroom. So I'm going to save you some writing now. This is the handout you need to be looking at right now. I'm going to point out some things, talk about some things. I'll probably then highlight some things on the whiteboard. Then we are going to take time to practice two complete problems. So interquartile range, that is what IQR stands for. What is the IQR? So I'm going to give you some definitions, some vocabulary words, formulas, whatever. It is Q3 minus Q1. Q3 stands for the third quartile. Q1 stands for the first quartile. Middle school books where this topic is normally covered, a lot of times they use the language, it's hard for me to say, UQ and LQ, upper quartile minus lower quartile. So those are all just synonyms. Q3 is also called the upper quartile. Q1 is also called the lower quartile. Well, what are these Q3 and Q1s anyway? Q3 is the median of the upper half of the data. Q1 is the median of the lower half of the data. I want to kind of talk about this stuff, so I'm going to go back to the whiteboard. You have this in front of you. The easiest way to kind of think about this is medians are really just measures of position anyway. We talked about that last time, right? You have to put your data in order. The median cuts it in half, 50% below, 50% above. Well, Q1 is cutting the lower half in half. Q3 is cutting the upper half in half. Thus, we have these 25%. Hence, why they're called quartiles. Okay. Now, according to the literal definition of the IQR, you would subtract Q3 minus Q1. So it's that distance there. You can also see why this is very resistant to outliers. The top 25%, I could add 1 trillion to those data points. It's not going to affect the IQR. I could take that lower 25%, move them down to 0. Still not going to affect the middle 50% IQR. IQR is very often called the middle 50%. Bringing back, well, I'm not sure if I'm reminding you of this or if this is the first time we've talked about it. So, the word percentile, I want to talk about that for a minute. This is a special word. It ends in I-L-E, percentile. For example, if you scored in the 80th percentile on your SATs, what did that mean to you? It did not necessarily mean you got 80% of the questions correct. Percentile, if you're in the 80th percentile, it means 80% of people did worse than you, or 20% of people did better than you, or you did better than 80% of people. That's what the word percentile means. So if you look right here, you can see why Q3 is also called the 75th percentile, because it has 75% below it. Q1 is the 25th percentile. It has 25% below it. Of course, the median is the 50th percentile. So until we get to probably the next video, we only have a couple of percentiles that we can get from this information. So that is the measure. Oh, I did want to give a real life example. I did not pull it up, but many times seniors in high school, when they are trying to get an idea of the SAT scores needed for a particular college, they can pull up that information, for example, on the JMU website. Now, first of all, JMU knows two things, as all universities. They know that they cannot just state the mean or median, that's only half the story. But they also know that most people have not just had a stats class, and they don't want to use language such as IQR. Most of the general public is not going to know what that means. So I'm going to make up numbers now, but JMU would say something like this. The median SAT score for incoming freshmen is 1,200, and the middle 50% score between 1,100 and 1,300. That's the sentence that they use. In that sentence, they actually just gave you Q1 and Q3. If you wanted, you could calculate the IQR, but they're trying to tell the general public, hey, the middle 50% score between 1,100 and 1,300. And they hope that the general public can then figure out, oh, 25% of students score above 1,300, 25% of students score below 1,100. So they do try to make a complete sentence they feel like most people can understand. We do have our fourth numerical graph, and it is based off of all of this stuff. And that's what you see next, the modified box plot. Let me give you a little, I'm always complaining, right, about the Department of Ed and SOLs, etc. 10, 12 years ago in Virginia, that's all I can speak to, 6th grade covered this topic, but a much watered down version. simply called the box and whisker. Then they moved this to the Algebra 1 curriculum, and they did more of a modified box plot. It depended on the Algebra 1 teacher and also the textbook on whether they did exactly what I'm about to show you or if they did a slightly watered down version. So my point is, this topic of box plot, depending on what book, what internet site you go to, who knows what you're going to find. You have to use my template. I am doing the original. I'm holding to historical accuracy. I'm also supporting the main software, statistical software that JMU uses, biology, psychology, the researchers, etc., are using this exact template. I'm pretty sure a year and a half ago, they've actually taken box plots out of the Algebra 1 curriculum. You don't want to just learn what's part of a certain grade because you never know when they're going to move things around, put things back into a particular SOL. So we are still covering, of course, the modified box plot. So this was the problem. Up until this graph, everybody sort of had their own opinion as to when they looked at a data set, if a particular data point seemed kind of big or kind of small, and should we call it an outlier or not. It was really just up to your opinion. There was a statistician, a researcher named Tukey, you don't need to know his name, but he wanted to come up with acceptable criteria that everybody could agree on. And this is exactly what he came up with, the modified box plot. From this template, he not only wanted everybody to agree on whether a data point was an outlier or not, but he also wanted to distinguish between mild outliers and extreme outliers, meaning, oh, that data point's kind of big, or, oh, wow, that data point is way out there. If we're talking about the high end, same thing with the low end. So you definitely have a box. Left side is Q1, right side is Q3. The median is going to be wherever the median is. It does not have to necessarily be the middle of the box. Then we have what we call two outlier fences. Some people call them invisible fences, goal posts, whatever you want to call them. They are not technically part of the main graph, so that's why I've labeled them sort of a little bit below. This first fence, these are formulas. Q3 plus 1.5 times IQR. Tukey is the one who came up with these formulas. This one is Q3 plus 3 IQR. You have two more down here to memorize, and you do have to memorize these. But it's not that hard because these two, it makes sense that we're going Q3 plus, since I'm getting bigger. If you look down here, I'm getting smaller than Q1, so that's why these formulas start with Q1 minus. But the endings, you can see, are the same. The first fences is the 1.5 IQR. The second fence is the 3 IQR. So you're going to work through these formulas. You're going to have numbers here. Then you're going to actually look at your data set to see if you had data points fall in this area. If you did, it's called extreme outlier. Or if you had data points fall in that area. If it did, it's mild outlier. Same thing on the low end. Here's probably the most confusing thing, and I think it's confusing because many people have only done a box and whisker. That is not what we're doing here. So these whiskers, I put a little star right here, they extend to the highest and the lowest data points that are not already outliers. Let me go back to the whiteboard just for a second. And you'll see how this works when we actually do some problems. Let's say you identify two data points that are extreme outliers. And let's say you have another data point that happens to be the mild outlier. Then this whisker is going to extend to the fourth highest data point. This is assuming you have your data in order, right? you don't have to see these numbers, but I would start here at the bottom and I would look at my high data points, figure out if they're outliers or not. Then I could, if I had 3, I could mark them off. This would be the next highest data point. Most students prefer when I say it like this. The whisker cannot cross the fences. The whisker does not necessarily come up to the maximum. It's going to come to the biggest data point that we did not already use as outliers. When it comes to box plots, I've seen a lot of funky ones. Sometimes there is no outlier because maybe the 4th highest data point happens to be Q3. Well, you have nowhere to extend it. I've seen box plots that have no whiskers on either end. I've seen box plots where the median is actually Q3. So that's actually really weird. It's even hard for computer programs to indicate that to you. Usually when we do it by hand, we'll make it just kind of thicker and we'll label it with both. So we are trying to indicate, yes, that's the median and that's the Q3. So you never know what you're going to get until you actually work through a problem. While we're here just on the notes, and again, we're going to think through this on the 2 examples we're about to do. I personally prefer to see skew on a histogram or maybe even a stem and leaf. Sometimes, not all the time, sometimes it is easy to tell skew, right skew or left skew, from looking at a box plot. Sometimes it's not. The only ones you're going to be held responsible for are the ones that clearly show it. So, for some reason also, most of the data sets I ever do in the classroom, if I'm going to see skew, it seems to turn out to be right skew. I mentioned that when we were talking about skew, that I seem to see right skew graphs much more often than left skew graphs. So that's why I wrote the clues for right skew. The right whisker is longer than the left. The median is to the left of center of the box. And then the third clue is if there's outliers, there don't have to be outliers, but if there's outliers, they better be on the right-hand side. If any of these clues contradict each other, those are the ones I'm not going to ask you about because they are not the clear ones. All right, we're going to practice a problem. This is your template. So we're going to do one together, then I'm going to let you do one alone. I would keep this in front of you. If you can make a box plot by looking at this, then you know all you have to do is then memorize this, right? All right, we're going to do some of your social media, so have your survey out. I did already take a look at this. First of all, remember, the right-hand side is ordered by column. That's going to be much easier for us to look at. So I'm going to go ahead and fold this in half. Also, remember before break, we talked about how we are not going to include all those zeros because I think that meant you didn't understand my unclear question and that you actually don't have an account. Let's do the Instagram. So first of all, mark off your 0 because I don't want that to confuse anybody. Okay, Instagram. I would like you to pause the video and take 2 to 3 minutes to see if you can figure out what Q1 median and Q3 are. Remember, you want to find the middle point, which is the median. Then you want to find the middle of the lower numbers and the middle of the higher numbers. Take a minute to do that. Okay, so hopefully you found that the median is the data point 1125. From doing this in the classroom in the past, I know the next step, sometimes students get confused. There was actually an odd number of data points, so he was the precise middle, okay? If you want, on your data set, you could then just put a line through 1125 to really give yourself a wall between the lower half and the upper half of the data. 1125 is not part of the lower half now. It is not part of the upper half now. So don't include the 1125 when you start to look at the 1093 to the 73. This is now the lower half. This is now the upper half. So if you find the median there, you should find that Q1 is 782. And if you find the median there, you should find that Q3 is 1878. Okay, so make sure you see how I got those three numbers. I'm going to put this up way over here so we don't forget. That right now is all you need to be able to work on the template for the box plot. Okay. Box plots can get a little confusing if you try to do them to scale. If you try to put a number line here, because by the time you end up calculating the fences, it's like you're off your paper or I'm off my whiteboard. So this is the only graph that I tell you you do not have to do it to scale, but absolutely everything has to be labeled. So we've got our box. The left-hand side gets labeled with the Q1, 782. Right-hand side, 1878. Now we got to figure out where to put the median. Basically, you only have three choices. Is it dead center? Is it somewhere to the left or somewhere to the right? Sometimes it's easy enough to eyeball it to figure out if 1125 is closer to the 782 or closer to the 1878. But if you're having trouble with that, make sure you understand that you could figure out what the middle of the box is just by averaging those two numbers. If you want to think about it as a midpoint, right? The middle of that box turns out to be 1330. So yeah, 1125 is definitely lower than 1330. It's to the left of the center of the box. Okay. Now we have to do our outlier fences. All right, this guy is Q3 plus 1.5 times IQR. You could write the whole formula there, but maybe we should go up to the top and figure out what IQR is. Q3 minus Q1. That turns out to be 1096. Okay, this is probably the most common mistake I see on test, that people did not learn what the IQR formula was. It's 1096. Okay, so we're going to figure out what 1878 plus 1.5 times 1096 is. I'm doing it myself. Yes, 3522. Now, make sure you know what I'm labeling. I'm labeling the fence. I'm not labeling space in between. Now, I'm going to actually look at my data set for the Instagram. I absolutely see that we have a data point bigger than 3522. I'm looking at the 6245. So, we now know we have got to check the second fence. That is Q3 plus 3 times IQR. Let me figure out what that is. 1878 plus 3 times 1096. 5166. And again, I'm labeling the fence. Okay. We'll come back to the left side in a minute, but let's keep focusing on the right-hand side. So now I'm going to actually look at my data set. 6245. He is an extreme outlier. You do have to label all outliers. So 6245 is extreme. The next highest data point, I'm looking at the data set, is 2295. Oh, he's not there, he's not there. Okay. 2295 must be the end of the whisker. So I don't have any mild outliers. I have one extreme. 2295 is the end of the whisker. Let's check the low side. This one is 782 minus 1.5 times IQR. Now, hopefully most of us can see that's going to go negative, meaning we don't have any low outliers, but for assessment purposes, you do actually have to calculate that and show me what negative number you got, just so I'll know if you used the right formula. Negative 862. That is that fence. Since I don't have any data points falling below negative 862, I can cheat and not show the next fence. So the whisker is actually going to come to the minimum on this one, which is 73. Instagram, yeah, 73. I want to show you the minimum you would have to give me on a test to get all of your points. Of course, you should always show me more, because if you mess up something, I want to be able to give you partial credit, right? But usually at this point, I'm asked by students, what's the minimum to get all of my points? You don't have to show me that work. You should, but you don't have to. That should be on your paper somewhere, but I'm trying to show you the minimum. Everything in this circle you would have to have on a test. This is not a negative sign. That was part of my arrow. Maybe I need to move him closer to get all of your points on a test. Now let's see if we can identify skew. Since I told you that you don't have to do it to scale, how are you supposed to figure out the length of the whiskers? See, clues for right skew immediately jumps out because we've already talked about it. Number 2, the median is to the left. So, if I just look at that, I'm thinking, oh, maybe there is right skew. But let's look at clue 1. The right whisker is longer than the left. How are you going to figure out what the length of that whisker is? Well, think about it. If it was on graph paper, that whisker is going from 1878 to 2295. Let's do the math. The length of that whisker is 417. I'm just going to write that down there so I don't forget. What's the length of this whisker? Well, bigger than 417. 782 minus 73. The length of that whisker is 709. So, on this box plot, the left whisker is longer. Okay, I've already gotten contradictory clues. This is a fantastic example of when I would not ask you to identify skew off a box plot, because this is contradicting itself. And from a real life reason why, there was only one data point that was really messing everything up. Everyone else ranged from 73 to 2295. Then there was this massive number of 6,245. So one data point, while he is absolutely an extreme outlier, he's not enough. There weren't enough data points to really indicate skew, because skew is more of an explanation for a data set as a whole, as opposed to, oh, I had just one data point that screwed everything up. All right, what I want you to do now, so this is absolutely where you pause the video, do what I asked you to practice, come back in 10 or 15 minutes or whatever. The dentist brushing teeth data set. First of all, it is not in order. You have got to put your data points in order. You have to find your Q1, median, Q3. Do the complete modified box plot for this brushing the teeth data. Do that, then unpause your video, and we'll put the answer key up. Okay, so first, just in case you have those wrong, pause again, see, because if you have messed up those, everything else is going to be messed up, right? In case you got that part wrong, I want to help you before we keep going. When you put your data in order, there were 20 data points here. There was an even number of data points. So the median actually fell between these two 45s. So if you average 45 and 45, of course, you get 45. But I really like the visual of putting a wall in between, because then what happens is those 10 data points are the lower half of my data set. I, again, have an even number. So I'm averaging those two number 30s to get Q1 of 30. Much more interesting on the upper end. The upper 10 data points are my upper half. Q3, the median, is in between 90 and 120. So you have to average 90 and 120 to get 105. Okay, so make sure you're okay with that part before we keep going. And if you had those wrong, you probably want to redo your box plot now, then come back to the answer key. I'm trying to think ahead as to where people mess up this problem when we're doing it in the classroom. Remember, IQR is the width of the box, basically, that middle 50%. 105 minus 30 is 75. So work through your formulas for your fences. I did my first fence, 217.5, and I knew that I had a data point bigger than it, so I had to check the next fence. Then I look at my data set. 240 was my biggest number. The next biggest number was 150. 150 does not make the outlier region, so 150 is the end of the whisker. Over here on the left, again, as usual, it goes negative, so I don't need to check the second fence. So actually, the whisker comes down to the minimum. So that is the complete box plot. But let's talk about skew now. Let's check to see if it's right skew. So yes, the median is left of center. Okay, the right whisker. These numbers are easy enough. You should be able to do it in your head. That's a length of 45. 150 minus 105. Length of 45. That's a length of 15. Right whisker is longer. And then if there's outliers, well, we do have outliers. They better be on the right. They are. So this is an example of what I would ask you on a test because all the clues say the same thing. We absolutely clearly can tell right skew from this box plot. There were a few other questions on here. Some are not appropriate. I stole this from my Math 220 class, but some are appropriate. So I just want to look at a few of these questions down here. Sample mean. Well, take the time, add up all 20 numbers, divide by 20. Maybe I should erase this. We're still on the dentist, but if you add up all 20 numbers and divide by 20, you will get sample mean is 70. Part B, it says, if these times were a population, calculate the population mean. If you look back in your notebook, it's the same formula to calculate the mean. It was only a matter of how I referenced you. Am I viewing you as my sample, or am I viewing the data set as the population? But the formula was the same. Add them all up, divide by how many. So these are the same number. C, we already know. And as soon as we look at the mean is 70 and the median is 45, when we're talking about brushing teeth times, 70 is considerably bigger than 45. So that is what D is trying to get at. Which one is better and why? If you were answering these before you did the box plot, I'm just really trying to get you to think and look at the data set. The median is better because what has happened is we had some high values, some people who are really into brushing their teeth, and those couple of high values, high data points, pulled up the mean, really indicating right skew. I see right skew just from looking at mean and median. Doesn't even matter that I did the box plot, right? So if you hadn't done the box plot, it would probably make sense that you would mention the 240, maybe mention the 150. Some students might even mention 135. Because again, this is just you looking at the data set saying, I had 20 data points, but 3 of them seem to be extra high. We don't want 3 data points affecting the entire data set. So you absolutely should be using the median. We are not doing E and F. We did G. So part J is just making sure you know synonyms. The 25th percentile is Q1. That was just making sure you knew that Q1 was the 25th percentile. All right. That's it for lecture notes. I just want to put up your homework and make sure we're all on the same page. There is actually going to be a homework you're going to turn in via email. Let me get that up also. kind of similar to the categorical data homework, that you're going to collect data all on your own somewhere in your life. You're going to collect numerical data. You do have to have at least 25 data points. Don't collect too much data, because remember, you're going to have to be putting this data in order. So keep that in mind. 25 data points probably is very manageable. This part right here, if you don't remember what range is, it's max minus min. Your data has to have a range of at least 15. Meaning, for example, you cannot ask all your friends, how many dogs do you have? Because that would probably range from 0 to 8. Most people don't have more than 8 dogs. And that range is only 8. So you want to have a wide range of numbers, or if you don't, your box plot can get really messed up. You're going to do neatly by hand. This is not an Excel assignment. Excel is very tricky to do correct numerical graphs on, so you're doing these by hand neatly. For this homework, you're just going to do a histogram on that data set and the box plot on the data set. Then you'll take smartphone pictures and you will email them to me. Much better to email me directly than to try to use Canvas. All right. Do all of this, get really good at box plots before you watch the next video. See you soon.